Hello again, YouTube. I'm doing part two. We have a double header going on today. So I'm going to continue on with the last question I left off at, and we'll just go for maybe 15 minutes again. So I'm going to jump right in there. I'm Greg from Greg's Tutoring, NYC@gmail.com. I'm going over some SHSAT-like problems that were on regions from a long time ago. And part of the common thread here is that even though they're not quite 100% SHSAT questions, some are challenging, and some also, I want to show you how the numbers kind of work in your favor, and that sometimes you actually don't need to go through complicated math. I think the last example I used in the part 3 had some complicated division, but the SHSAT normally doesn't go that far. So it goes a little deeper conceptually, but not on there. Nonetheless, some of the fundamental techniques are still the same here. So 544 is asking us to look at the difference between the greatest common divisor of two numbers and the least common multiple. So there's a technique to do both of them simultaneously. So if we list the numbers, and then on the side we start looking at their prime factors. So 2 goes into here 15 times, here 21 times. There's no more 2, so we start with 3, and we get 5 and 7. We're done. Okay? So this is the GCF, and the L shape is the LCM. So this is 6, and this gives us 6 times 5 is 30, and then we get 210, and then we subtract, and we get 204. So this one's easy, which is a matter of doing it. You can do the prime factorization. These are both not too bad numbers, but this is a way to do it simultaneously together, and you can certainly do the other technique with the hierarchy, or even just listing out factors as the way to do it. And all they're asking you to subtract the LCM from the GCF. Okay, that's 544. 552 is the next more kind of complicated one. This one's a little more complicated than the one we just solved at the end of the other one. It's more complicated kind of conceptually, but it's easier to solve. So if you remember, we're trying to get 3 numbers, a times b times c over x times y times z, to be equal to 1. So if we're solving for something on the denominator that we multiply both sides by that, we can solve for it. So the goal in these kind of problems is to create a fraction where what you're looking for is at the bottom. Okay? So with that in mind, we have 18 men can dig a trench 30 yards long. So that's what they're shooting for. And it took them 24 days and 8 hours. So I'm going to write the 30 over here. Okay? And the other one is by how many men, so we don't, that's what we're looking for, can dig a trench 60 yards long, right? In 64 days, working 6 hours a day. So once we just set it up, this is our info for the one thing, and that's its inversely proportional result, and this is for the other one, that's its inversely proportional result. But we're going to multiply across on each, and let's see what we can cancel. So this 8 makes that 8, this 6 makes that 3, this 8 makes that 3, right? And this becomes 2. So we canceled everything, so we get 18. That would be the answer. Because basically we're solving for x. If we multiply both sides by x, that would equal x then. And you can go plug it back in too and follow it. What we're trying to get is the ratio. There's a rate here involved in here. In other words, if this many people did this in the many days and this many hours, and they got 30 things done, there's a certain rate there that when you apply it to the other one, it'll be equal. All right, so that's 552. 567. Okay, we actually solved 516, 67 on another one, and we got an answer of 14. That wasn't too hard to do. We just listed them out. and we use that same technique. We got 84, 140, 91, and 126. So I'm only trying to look for primes over here. And the other scenario, we could keep going. And this one, we wanted to stick with that. So I notice that's a 7, that's a 7, and this is actually divisible by 7, so this is worth knowing. So this gives us 12, 20, 13, and 18, right? And then there's nothing else common because that's prime, so we're stuck. So we get 14 there. That's what we get 5, 6, 7. We had solved that already. So now it tells us as a part 2 to that, suppose that each board is 8 inches wide and the fence is 5 boards high. Okay, how many square feet of boards will it require? So what we need to do is go back. So if we have four sides, that's the 4 numbers there. So what we want to kind of do is unravel it. That's our 4 parts, and find out the length of the whole thing. All right. So if we have, what do we have? 168, 280, 182, and 252. There's a lot of numbers here, and it's easy to mess this up or whatever. So 8, 9, 10, 12, 1, 16, 17, 23, 28, and 2, 4, 6, 8. So that's 882. Okay? So we're trying. So the length of this whole thing is 882. Now, if there's 14 boards, we need to figure out how many boards there are going at least one level. Saying they're stacked 5 high. Okay, let's figure out how many boards there are. So if we have 882 divided by the 14, 570. There's 18, so it's going to be 6. 24, 2, we get 84, so we get 6 here. 84, we're left with 42, and we get 3, I believe, right? Yes. And we can double check that by doing 14 times 63 and getting it out. So we have this way going across 63 boards. Okay, now it tells us they're stacked 5 high. So if we have the visual representation of that, we have 282 across 63 boards. They're stacked 5 high. 1, 2, 3, 4, 5, and each one is 8 inches. So we have 40 inches is really what we're looking at here. Okay. And we already have the 14 that we got before. So each board here is 14 feet. So we can convert everything to inches or not. So it's asking for square feet. So this is the same as what? 3, that gives us 36, and 4/12, which is the same as 3 1/3. Okay. So basically what we want to do is multiply the 63 times the 3 1/3. So we have 63 times the 3 1/3, because this is the number of boards times its height times the number of boards there are. So that's what we're shooting for here, right? So we can make this a fraction. This is the same as 14 times 63 times 10/3. Okay. This 3 can cancel that out. We get 21. So we're left with 14 times 21 times 10. So we can either make it 140 times 21 or 210 times 14. 048, 012, we get 049, 2940, and that should be our answer. Yep. Okay, 612 is the next one I noted. 612 is a doozy of a problem. It's actually harder than it looks, because it's involving a whole bunch of wacky math and so on. Let me just make sure we're live. My throat's going out on me. All right, so we have what do we have? We have the circumference of one carriage wheel is 13 feet 9 inches. And we have another wheel that is slightly larger, and its circumference is 16.5 feet. All right. How many more times will one turn than the other in going 30 miles? All right, so we're back to needing to know how much feet is in a mile. So this comes up a few times in some of these. You guys should know that. We don't really care about the diameter, the circumference in this example. I mean, the radius. We do care about the circumference. So what we have is an A and a B, if you will. So what we need to figure out is how many times this goes, how many times it goes one full revolution over the 30 miles versus the number of times this goes the 30 miles, how many revolutions that is, and then subtracting them. So what we have is 30 miles times the 5280 feet per mile, okay, divided by the circumference. So in this case, it's 13 3/4. So we wanted to try to avoid seeing what cancels. So we can make this 13.75, or we can make it into a fraction, a top-heavy fraction. So we get 26, 52, we get 55 fourths. Okay? So we have this divided by this. So that's the same as 30 times 5280 times 4 over 55. Okay, there's not much you can do with that. So we're already seeing that this is kind of annoying, because what we can get is 5 can go into here 11 times, and here into here 6. And there doesn't seem to be anything that's obvious that can cancel. It doesn't look like it can go into here, and maybe it can. Let's see. 11 goes into 5280. That's 4 times. We get 44. We got 6 left over. That's 6 times. No, we're not going to end up with anything able to do that, right? So what we're going to get on this side then is 5280, and then these two times 24. Okay. So this is where it's easy to make mistakes. So 0, 2, 3, 8, 9, 10, 11, 1, 21. And this is 0, 6, 1, 5, and then 10. That's a 0, not a 2. So we should have 0, 2, 7, 6, 2, 1. 126,720, and now we need to divide that by 11. So hopefully the numbers will work out. So 1, 2, 6, 7, 2, 0. That goes in there once. We get 1 left over, and this it goes in once again. We get 557. So that goes in there 5 times. We get 2 left over. This becomes 2. So we get 11520 revolutions for the first one. So we have to do an analogous computations for the other side. So it's 30 times 5280 divided by, and again it's the same problem until we leave it as a fraction. So we have 16 and a half. That's equal to 33 over 2. And if we divide, we end up bringing this to the top and that to the bottom. But just to be clear, it's 30 times 5280 times 2 over 33. So we see we can divide by 3. Okay, so hopefully the 11 works in our favor on this side as well. All right, so we have 5280 times 20, so we could just add it twice or whatever. I like to avoid on these because there's a few numbers doing it in my head. So 0, 6, 1, 5, 10. So 10, 560 plus this 10, so that's a 0. So now we need to do 11 dividing into 105,600. So it doesn't go into here, it goes into 1. We get the 99, we're left with 6, right? Wait, I put 1 there, that should be 9. And we get 66, and we get 600. So these are our two numbers. So now we're going to get 11520 minus 9600. Okay, and we get 0, 2. We're going to borrow here. So that's 9. That should have been 0. So we get 1920. What question was this? 612. Yes, that's 1920. All right, let me just make sure we're live. And I'm going to do one more question, I think. So let's see what the next question is. Keep this small and tidy. Yes, this one. So this one was annoying because of the way it's worded. And there's a slight catch to it, which is the word add to, the phrase add to. So a man was asked his age. He replied, add 2 its half, its third at 3 times 3. The sum will be 130. So the inclination of everybody is to write x over 2, which is age, plus x over 3 plus 9 equals 130. But that would have been what it says if it just says if you added its half, its third, and 3 times 3. But it says if you added 2. So we have to put this over here. Okay, and this is pointed just algebra. So we're going to subtract 9 from both sides, and we get that. Okay, so we're going to get rid of these. We could do common denominators, but we could just start going. Multiply everything by 2. So we get 2x plus x plus 2x over 3 equals 242, right? And then multiply everything by 3 to get rid of that. So we get 6x plus 3x plus 2x equals, and then 242 times 3 is 6, 12, 1, 6, 7, 26. So we have 6, 7, 8, 9, 10, 11x equals 726. And hopefully that, it's funny that 11 comes up a lot, right guys? 726 divided by 11. 7's too much, 6. 66, right? We get 6, and the answer, the guy's age is 66. And if we plug it in, we get 66 plus 33 plus 22 plus 9 equals 130. Get 99, 108, 120, 130. There we go. All right, that's what I'm going to do for today. Maybe I should put up a teaser. Let me see for the next time. All right, this is almost similar to some of the ones we did already. Not quite. This will come up on the SHSAT as well. Not as strictly in this raw form, but it might give you an illustration or a word problem where somebody did something and so on or whatever. And this might be the second half to it. that once you quantify, like try to figure out the 2 acres or the 3 days, then it's going to flip you into that. So this definitely needs to be your fundamental aspects. All right, so please like, please subscribe. I'm Greg from Greg's Tutoring, NYC@gmail.com. Please email me your grade 8 and grade 9 SHSAT problems, as well as anything else. You got about 70 days left until the SHSAT. Peace out.